Let me tell you what nobody in QA talks about honestly. Everyone talks about fixing flaky tests. Nobody talks about the 6 hours you work before you even know what to fix. Every sprint, my team was losing half a day to manual triage, pulling logs by hand, cross-referencing CI history, forming hypotheses, writing up findings for stand-up. And at the end of all of that, sometimes the root cause was a 200 millisecond timing window or a test database that hadn't been seeded correctly. 6 hours. For a 2-line fix, I built a 4-agent AI pipeline on an 8N with LangChain and Claude Sonnet. That brought that 6 hours down to 22 minutes. Today I'm walking you through every agent and the actual Python code. 4 agents, 1 goal. Each agent has exactly 1 job. Let's look at the watcher. Agent 1, the watcher, sits on top of your CI Webhook stream, passes every test run result, frags any test with an inconsistent pass/fail pattern and classifies the failure type. Agent 2, the investigator, pulls the full run history for flagged test logs, Playwright traces, screenshots from the last 30 days. Agent 3, the analyst, takes that correlation report and feeds it into Claude Sonnet with 30 days of historical debugging notes. It returns ranked root cause hypothesis with confidence scores. Finally, Agent 4, the reporter. Agent 4, the reporter, takes the output, creates a Jira ticket with a suggested fix, and posts a brief to Slack. The stack is straightforward. Then 8N for orchestration, LangChain for the agent chains, and Claude Sonnet as the backbone. Here's the requirements file. Nothing exotic, just Playwright, LangChain, Anthropic, and the SDKs. Now let's build them. Starting with Agent 1, the watcher. The watcher does 2 things: classify the failure and detect flakiness. First, the failure classifier. We define categories like timing, selector, and network dependency using regex patterns. Pattern matching on the raw error message. Order matters here, timing patterns are checked before selector patterns. First match wins. Now the flakiness detector. It tracks the last 20 runs. We define a flaky test within a specific pass rate window. The 15-85% band is the genuine flaky zone. Higher is just a blip, lower is a broken test. This feeds directly into Agent 2. Agent 2, the investigator. It passes Playwright traces and builds a correlation report across 30 days. Playwright trace files are zip archives containing JSON event streams. We open the zip and extract all trace events. We surface 2 key signals: network call slower than 2 seconds, and the first action that threw an error. Those 2 things point you directly at where the test broke and what was slow when it happened. Now correlation, this is where the real pattern detection happens. We check time of day, does it fail more when the DB is under load? We check preceding test, does it always fail after a specific other test ran first? That's a test isolation problem. Browser breakdown and parallel execution rate. Fails only on Firefox or only when running in parallel. Those are big clues. The output is a structured JSON report, no walls or logs. This takes 3 minutes to generate versus half a day manually. Agent 3, the analyst, this is the LLM brain. It takes the report and team notes to return ranked hypotheses. We set temperature at 0.1. You want the model to be analytical and consistent, not creative. Standard for structured tasks. The system prompt enforces a strict JSON schema. We want rank, root cause, confidence, evidence, and a fix. We define confidence tiers. 85% means a strong pattern and specific fix. Below 65%, we recommend more monitoring. JSON output parser ensures the schema. If the model drifts, the parser raises an exception, keeping the pipeline robust. Here's a real output: test, isolation, failure, checkout, flow, leave, shared DB state. This is what your engineer reads at standup. It identifies the issue and suggests a fix in minutes. This cuts out the morning triage log entirely. Agent 4, the reporter. It takes the analysis and automates the paperwork. No human writes these tickets. It creates a Jira ticket with a full analysis. Priority is set automatically based on the confidence score. Labels include the failure type classification so your bot can filter by timing or tighter race issues automatically. Then the Slack brief. It posts a condensed update before stand-up using color-coded emojis for urgency. Your team knows instantly if it's a fix now situation or watch it before the stand-up call even starts. Finally, the orchestrator. This stitches it all together. It's the single function that runs when CI fires. It checks for flakiness, builds reports, runs LLM analysis, and sends the reports. One function call, 22 minutes word time. Let me give you the real numbers after one full sprint of using this pipeline. Root cause analysis time went from 6 hours down to 22 minutes. Resolution time dropped from 4 days to 6 hours. Engineer time spent on triage per sprint down from 40% to 5%. Jira ticket creation fully automated, 0 minutes. The pipeline actually writes better tickets because it has access to 30 days of data and never gets rushed. But I want to be straight with you. There are 4 things you need to know before building this. 1. It finds tests faster, it doesn't fix them. 2. The analyst is right about 80% of the time. Treat it as a starting point. 3. You need at least 2 weeks of history for patterns. 4. Budget a full day for the N8N setup. If your team burns more than 2 hours per sprint on triage, build this. The architecture is tool agnostic. The full code is linked in the description. Swap the tools to match your stack. It translates to anything. For more on AI agents and QA automation, check out the series on YouTube. See you in the next one.